the problem. Now you see a network diagram problem over here, and we are going to be doing a solution of how to do this problem. So the question that's given to you is just this. Sometimes they might even give you a diagram and they will ask you to fill in the blanks, just like what you see over here. But a lot of times, which is a majority of times, they will ask you just this question, and then you will have to construct this drawing. And again, it has to be constructed really quick. For every question on your exam, you have a minute and close to 20 seconds to answer. Now, in that minute and 20 seconds, you have to read this whole thing, draw this whole diagram, and answer that one question. Sometimes on one diagram, on the same diagram, they can ask you 3 different questions. But unless you practice how to draw this diagram like maybe 10 to 15 times and understand exactly how to do this, you won't be able to finish it in a minute 20 seconds. But once you practice, you'll probably be able to finish it in 40 seconds. So for this, you have to practice with different numbers and different scenarios and look for questions on how they frame the questions and how to draw this. So it needs quite a bit of practice. It's not really easy, or it's not like you just do it one time and you already know how to do it. You will not. You will forget during the exam, and unless you have practiced really good. So I would say on the network diagram, spend at least one day thoroughly to understand how this works, and before the exam again practice a few problems. So now this is a problem showing activity on the node. Now the nodes, these are the nodes, and these are the arrows that we were talking about before. Now using the precedence diagramming method, the question is over here. We have to answer all these questions. What is the critical path? What is the duration of the critical path? What is the float of activity on one of the activities? What is the float of activity on the other one? Explain using different techniques. Now this is what I'm going to show you, how to use different techniques to solve this problem and to get these 4 answers. So the 8 questions that you get are going to be majority from these 4. And again, they are not tough, they're really easy. It's just you need to understand really well. So first, we'll understand how our node is set up. Now everyone sets it up in a different way. You could set it up in your own way as far as you remember, and the only way to remember is making a few network diagrams on your own, so you have your own node template and see how you want to put it. So in my case, I put in an ID, which is over here JKLMNOPQR. On the question, the ID could be named as a certain name, or it could be named as a number or a letter. So don't get confused with that. Then the next one is ES, which is right here, which we need to find out, which is early start. The lower one is the late start, which is right here. Now you know we have early start and late start. If I need to find the slack, then I can just subtract these two and then find the slope. So that's one of the ways of using that, using the forward and the backward technique. But eyeballing technique is really easy as well. And the last one in my node is the duration, which is the time which will be given to you in your question as well. So the way you will start is they are giving you activity J can start right away. So you start with something where to start. You know, this is my start. I'm starting right here. And I know activity J can start right away. It doesn't have any dependencies. It doesn't need to start after a certain activity. So this is where my drawing starts. So I will make a box or a node with the activity J. I put in 2 days, which is right here. And the next one is activity K. Now it says activity K, the duration is 3 days. And activity L, the duration is 4 days. Now these 2 activities can start only after activity J is complete. So when you are placing your boxes or nodes, make sure you start with the activity J because that's where it starts, and activity K and L are going to be after the activity J. So it's coming, I'm drawing it on the right side. And try to put it in line, because if I put activity K over here and I put activity L somewhere over here, then putting in the arrows, it gets messed up. You have to make sure you keep your diagram clean so the arrows are not crossing each other, so you have enough space. So make sure the activities are lining up in the right rows, in the right columns, and that's what you will avoid making mistakes by just confusing yourself as one activity is somewhere else and you put another activity somewhere else. So you have to draw it in order and right after each other, and again you can do that only after practicing like 7, 8 or 10 problems. So I put K and L right after J because I know these two activities cannot start till activity J is complete, which is 2 days. Now I'll go to the activity K and L. We already did that. We go to activity M, and what it says over here, M takes 5 days and can start after activity K is finished. Now I know M is dependent on K, so I better put M right next to K. I don't want to put M right here because then all my arrows are going to crisscross. So I know M is dependent on K, so I put a box over there, put it as M, put the number 5, which is 5 days. Let's go to activity N, and activity O takes 4 days and activity N takes 1 day and can start after activity L. So this is activity L, and I have 2, which is N and O, which are dependent on activity L, so I'm putting it in the same line. I don't want to put these two anywhere else on this page because again it will create a problem where arrows overlap each other. N takes 1, O takes 4. I'm just filling in the information. Now we have activity P, and can start after activity N is complete. So I go right on N, and I know P should be put right over here. Again, it takes 2 days. Let's go to the next one, activity Q, which takes 3 days and can start after activity O is complete. So I go close to O, and on the right I put my Q. And Q cannot be completed unless O is complete. So Q is dependent only on O. Now we have R can start after activity M, P, and Q are complete. Now you see this? Where should I put R now? What is the best location for it? So I find this is the best location because it keeps the drawing clean. And to finish R, I have to complete P, which is an arrow from P. I have to complete Q, which is an arrow from Q, and M, which is an arrow from there going to R. So this finishes the network diagram because after activity R, I am done with my diagram. I'm done with placing all the activities in the process that I was in. So now let's see, how do we calculate the critical path? Now critical path is defined as the longest sequence of activities in a project plan, which must be completed on time for a project to complete on the due date. So an activity on the critical path must be completed on time, and it cannot start until its predecessor activity is complete. If an activity on the critical path is delayed by a day, then the entire project will be delayed by a day. So again, what is the critical path? It's the longest sequence of activity in a project plan. So let's find the critical path. Now, longest sequence of activities. Now let's see how many sequences do we have from start to finish. So if you look at the diagram and just follow the arrows, so I'm starting from J, which is 2 days. I'm going up in this arrow, going to K, which is 3 days. So it adds up to 5. Go to M, which is 5, so 10. And then from there, I'm going to R, which is 4. So J, K, M, R, this sequence of activities gives us 14 days. So I just put it on the piece of paper, just like this. Now let's try what's the other sequence of activity that I can go for. I have to find all the possible sequences I have to go for. So the next one is J, L, N. I'm just following the arrows. P and Q. J is 2, 4, then that's 6 plus 1, 7, 8, 9, 10, 11, 12, 13. So J, L, N, P, R is 13 days. Now let's go to the last sequence that we have is J, L, O, Q, R, which is 6 plus 4, 10, plus 3, 13, plus 4, 17. So what is the critical path over here? Is the longest one is this one. From here to here till there to Q to R. It is not the most number of boxes that you see. It is the longest duration. So the longest duration in all the three, we have it as 17 days. So the answer for the question is the critical path for this diagram or for this question is J, L, O, Q, R. Now the following question for this is going to be, what is the duration of the critical path? And we already found that, that's 17 days. So the question could be either or. They might not even ask you what is the critical path, they will just ask you what's the duration of the critical path. And the duration for this question is 17 days. Now the third question is, what is the float of activity O and Y? Now the float on the critical path is always 0. Now the question they're asking is why? Because O falls on the critical path. Correct? So you have to remember that the float on the critical path, even L, the float should be 0, Q, it should be 0, J should be 0 as well as R. Everything on the critical path is going to be 0 float, because even if there's a 1, then an extra day is added to your project. Now let's see the next question, which is, what is the float on activity M? Now how do I calculate that? Now remember, we calculated the float using 2 starts or 2 finishes. We don't have those numbers over here yet, so you can find those using the forward and backward pass technique and find those 2 numbers and subtract to get the float. But the easier way of doing that is using the eyeballing technique. Now the way this technique works is, I take the sequence of my critical path, which is J, L, O, Q, R, which is 17 days, and then I take the sequence of the path which M lies on, which the node M lies on, because that's what I want to find the activity, right? And M lies on only in this one sequence right now, which is J, K, M, R, which is how many days? 14 days. So now to calculate the float, all I need to do is subtract the 17 from the critical path to the path that M lies on, which is 14. So 17 minus 14 days is 3 days. So the answer using the eyeballing technique is 3 days. Now this is the fastest way of finding the slope on your question, and majority of your questions are going to be asked just this way. But there might be a chance where you might have to perform the full forward and backward pass to find the slope. but 90% of the questions you can just answer the slope using this technique. And again, this whole process, putting it in the whole diagram, putting in the arrows, connecting them, calculating all the number of days, if you practice, you'll be able to finish it in like 30-40 seconds. If you don't practice, there's no way you can do it. So knowing the eyeballing technique is extremely important. Subtract it from the critical path wherever it lies on. Critical path 17 days, and M lies on this path, which is JKMR, and we just subtract those two. So first thing we are doing is putting in the diagram, calculating how many days does it take on that particular path, putting it on the piece of paper, and then the questions can be answered in a second. Okay, so that was the eyeballing technique. Now the other technique is full forward and backward pass technique that we are going to see right now. So for J, I start with 0, and it's going to take me 2 days. So I'm going to put 2 for activity K because that's the minimum time it's going to take me to start with activity A and activity L. K and L are dependent on J. So that's how we got a 2 there and a 2 here because they cannot start till after 2 days. Now when I go to M, M cannot start till K is complete. So K has a duration of 3 days. 3 plus 2, that will give me 5. So I got the early start for M as 5. Now let's go to N. Now N and O are dependent on activity L to be complete. So for activity L to complete, the duration of L is 4 and the early start is 2. So 4 plus 2 is 6. So N cannot start till 6 days. That's the earliest start. Same thing goes with 6 over here on N because 4 plus 2 is going to be 6. Again, you have to remember N and O are dependent on L to finish. Like if you would see it in the question, N and O can start only after activity L is complete. Now we gotta go to to activity P. Activity P is dependent on activity N to be completed. So activity N has a duration of 1, early start of 6. So 6 plus 1 is giving you a 7 as an early start for activity P. Now when it comes to activity Q, what is that dependent on? Activity Q can start only after activity O is complete. So we have O here. For O to complete, it is 4 plus 6 is 10. And now what we have over here is the last activity, which is R. Now R is somewhere where we have a join where we have M, P, and Q going into it. So we have to read over here in forward pass, that's where we are going. In forward pass, use the highest value on a join, and the join we have it over here, which is on R. So what is the highest value? The highest value that we have coming from M is 5 plus 5, which is 10 days. On P, it is 7 plus 2, which is 9 days. And Q, which is 10 plus 3, which is 13 days. Now, with respect to following this, using the highest value on the join, so out of these three, which one has the highest value? And obviously is activity Q because it is 13 days. So that's why we get a 13 over here. So that finishes our forward pass. Now what we have to do is go backward and do the backward pass. Now one thing to remember on a backward pass is use the lowest value on a join. In the forward pass, we use the highest value on a join, which was 13. When we are going on a backward pass, we use the lowest value on a join. So let's see how we get to doing the backward pass. So to start with the backward pass, all I take is the 13 down here. Now R is going to P, R is going to M, and R is going to Q. So to get the value of Q, we have the late start, which is 13, minus the duration of Q, which is 3. So that gives us the late start for Q as 10. Now when we get to activity P, we are going to get 13 minus the duration of activity P, which is 2, and that's going to give me the late start for P as 13 minus 2, that's 11. Let's go to M. It's going to be the same way. It's going to be 13 minus the duration of M, which is 5, will give me a late start for M as 8. Now when I go to N, there's an arrow going from N to P, so we have the late start from P, which is 11, minus the duration for N, which is 1, which will give me a late start for N as 10 days. Same thing goes with O. I will take 10 minus 4, which will give me a 6. So we are done finding M, N, O, P, and Q. In our backward pass, we already found the late starts. Now when I go to L, this is where I have a join, because it's going from N and it's coming from O. So what I have to do during the backward pass, I use the lowest value on the join, which is L. So the lowest value over here is 6 and 10. So which one is the lowest? So the lowest is 6. So I'm going to take 6 minus 4 for the duration of L, and it is going to give me a late start of 2. Did you get it? So when I go to K, is there a join over here? No, there isn't. So all I take is 8 minus 3, and it will give me a value of 5 for activity K. But now while I'm going to activity J, which is where I started from, again I have a join, because it's coming from K and it's coming from L. Now what we have to remember is use the lowest value on a join. So there is 5 and there is 2. So the lowest value we have is 2. So we are going to take 2, and 2 minus 2 will give me a 0. And that completes my backward pass. Now if I want to find the float using the backward pass, I will subtract late start minus early start. So what I get over here is a 0. For activity L, the float is 2 minus 2. For activity O, the float is 6 minus 6. For activity Q, the float is 10 minus 10. And for activity R is 13 minus 13. So if you look over here, this is the best way to make sure that your calculation was perfect. The float on the critical path should always come out to be a 0. Now remember, we had another question. What is the float of activity M, which is this one? Now using the eyeballing technique, we found out 17 minus 14, which gives us 3, which was the answer for the slope. Really fast way, right? Now to find the slope for m using the forward and backward paths, what I will have to do is subtract ls minus es, which is 8 minus 5. Again, the answer it gives me is the exact same answer that we got with the eyeballing technique, which was 3 days. So we found the answers for these questions using both the techniques, which was eyeballing technique and the forward and backward pass techniques. Now there could be some more questions that will be asked on your exam. They might say, for example, in your network diagram, after you have already drawn your network diagram following the question, there might be a question over here saying that what if activity M was the duration of activity M changed from 5 days to 10 days? Now, what is your critical path? Now you see what happened there? Now if this changes to 10 days, which is 5 more days, then this will be 14 plus 5, correct? So that'll be 19 days. So when that happens, this one is no more your critical path. So the critical path is going to be JKMR. Why? Because it has the maximum number of duration, maximum number of days when you add it all up. So make sure for watching out questions something like that. Or they could ask you JLOQR on this sequence. What happens if activity Q duration is reduced to 2 days? Is it still going to be a critical path, or is it going to change? Now if 1 day is subtracted from Q, we are going to get a total of 16 days, which is still more than the other 2 paths. So the answer is going to be, it is still going to be the same critical path. So that finishes this example on network diagram, and it will help you pretty much answer all the questions that are there which are related to your network diagram. So now let's